Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2010 Calculus BC question number 1. This question also made a cameo appearance on the Calculus AB exam of the exact same year from the graphing calculator portion. The problem reads, there is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by f of t equals that thing, cubic feet per hour, where t is measured in hours since midnight. Janet starts removing snow at 6 a.m., t equals 6. The rate, g of t, in cubic feet per hour at which Janet removes snow from the driveway at time t after midnight is modeled by g of t equals that crazy piecewise function. Okay. I'm going to go and fire through the calculation parts of this problem. It's a calculator problem, so I'm hoping we can figure out at least how to work the calculator. But if we want to find out how much cubic feet of snow has accumulated on Janet's driveway, all we do is we integrate from the time snow began to fall until the time they want us to integrate until. And since the snow is modeled by that 7t function, I can really just type in f of t dt and punch that in the calculator. You end up getting 142.274. And again, I got that just by putting it in the calculator, so just check your Inspire, use the button commands. Shift plus is the hotkey for an integral. So pretty straightforward. In B, it says, find the rate of change of the volume of snow on the driveway at 8 a.m. Well, from here, that's going to be f of 8, which is going to be how much snow, the rate at which it's falling. And then I'm going to subtract g of 8, because that is the rate at which Janet is shoveling stuff away. So this is falling rate, and this is shovel rate. And what you end up getting is negative 59.582. And it doesn't ask us for units, so I'm not going to put any. But the fact that it's negative means Janet is shoveling faster than it is falling. So yeah, we got to get rid of that snow. And then came C. C was probably the worst question because you have to let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. And we have to express h as a piecewise function. Okay, this is actually not that easy. So we've got 3 separate functions on 3 separate times. So I'm going to say on the time 0 to 6, what we have is h of x is actually equal to the integral from 0 to, and I could call it from 0 to 6, but I want to be able to figure out how much snow Janet removed at any time. So I'm going to say 0 to t of g of x dx, and that's supposed to give me h of x minus h of 0. This is based on the first fundamental theorem of calculus. Now at h of 0, Janet actually snowed or shoveled away nothing, which means h of x really equals this integral right here. And so from here, and I apologize, it's not h of x, it's h of t. H of t. So if h of t does in fact equal the integral from 0 to t of g of x dx, then what you get is you get the total accumulation from 0 to up until 6 of whatever function this is. Well, that's going to be h of t equaling the integral from 0 to t of what function exists between 0 to 6. It's 0. So what you get is 0. Janet did nothing for the first 6 hours, but that's okay. She's gonna get busy in just a second. On the time interval 6 to 7. Well, again, I'm going to integrate once again a different version of g of x dx. And again, that's going to be h of t minus h of 6. And I'm going to clean up that right there. I think I accidentally put a 0 there. That's supposed to be a 6. Okay, so from here, what do we know? We know that h of t, I'm actually going to change colors here. We know that h of t will equal h of 6 plus the integral from 6 to t. And I'm going to go and change the g function because g, within the time interval 6 to 7, is actually 125 dx. So again, where did that 125 come from? I pulled him from the middle function, because we're evaluating the function on 6 to 7. Okay, well let's find out what h of 6 was. Well, h of 6, right, the integral from 0 to 6 of all of this snow accumulated was nothing, so we actually have 0 here. And this is going to be 125x on 6 to t, which is going to be 125t minus 125 times 6. Again, first fundamental theorem of calculus. They both have a 125 in common, so I can bust him out of there and call him 125t minus 6. So this function is the function that is valid between 6 and 7. The 0 is the function that is valid between 0 and 6. So we've got 2 of our 3 pieces already. Alright, let's keep on going. I'm going to switch colors again one last time, and now we're going to go from 7 to 9. Oops, not 9. 7 to 9. Well, again, what is that, right? Well, what is this? This is going to be the integral from 7 to sometime t of g of x dx. And again, using the first fundamental theorem, I'm going to get h of t minus h of 7. So we can then say that h of t is equal to h of 7 plus the integral from 7 to t of, in this case, instead of using g of t, I'll go ahead and use the function that actually exists there. So that's 108. 108 dx. Well, what is h prime of 7? Well, from here, remember, this function is valid all the way up until 7, so from here, if I punch a 7 into this linear function, I get 125. And then I'm going to integrate this guy. So he's 108x on 7 to t. So same thing happens here. You'll get 108t minus 108 times 7. You factor that thing out, and you'll get 125 plus 108 t minus 7. And these are your 3 functions right here. So if you wanted to culminate them into one big bad thing, I'll do it in white. It's going to be 0, 0, 125 times t minus 6, and then 125 plus, forgetting the number here, 108, 108 t minus 7. And then you put down the conditions. This is valid on 0 to 6, 6 to 7, and 7 to 9. And you put the brackets in appropriately. I believe it was like this and like this. So again, C, a really difficult kind of problem. There's a lot to it. So hopefully you guys understand that. I'm going to clean up the board real quick, and we'll be back in a flash. And we're back. It says, how many feet of cubic snow are on the driveway at 9 a.m.? So in order to find out how much cubic snow are in the driveway, it's like an inflow-outflow problem. I have to consider how much was already there, how much fell down, and how much was scooped away. So with D, it's going to be, well, how much was there from the beginning? 0. The problem told us that there was 0 because if you look at the top condition here. And then that's going to be plus the integral from 0 to 9 of f of t dt, because f is the rate at which snow falls. And then that's going to be minus h of 9. Now, if you're wondering why the h is not in an integral, remember, in part C, we determined that h was the result of the integral of g. So by taking h at its value, we are finding the total amount of snow that had accumulated from all of 0 all the way through 9. And so you just do this in the calculator. Once you figure all this stuff out, you get 26.334. Okay, and I think that will wrap it up for this FRQ here. As always, please leave questions and comments in the comments area, and we will see you in the next episode.